All right, so we're back to continue with section 6.1. We're working on practicing using the table to help us find probabilities for a standard normal distribution. So for this next one, we have z of 1.23. We want to find the area to the left of z. So again, we'll start by making a little sketch. 1.23 is to the right of 0. So we're looking at this for our area. Again, looking at our standard normal table, we have 1.2 for the whole number and tenths digit. And then the hundredths digit is 3. So 1.23 will be right here, 0.8907. So the probability of z being less than 1.23 is 0.8907. Okay, so now we wanted to find the probability that z will be less than negative 2.03. So this will take us some thinking. 0 is again at the center. Negative 2.03 is about here. And we want the area to the left of that cutoff. So using our 0 to, or our negative infinity to z table, the area to positive 2.03, 2.03. Two point zero is here, and then 3/100ths is this column. Where those meet, 0.9788. So the probability of z being less than 2.03 is 0.9788. But then for this, we really want the area in the tail. So that will be the complement. Remember that the total area under the curve is 1. So 1 minus 0.9788 is 0.0212. That's the area in the tail. Again, using symmetry, if the area to the right of 2.03 is 0.0212, that is also the area to the left of negative 2.03. So the probability that z will be less than negative 2.03 is going to be 0.0212. Okay, next one will be a little simpler. We wanted the probability that z will be to the left of 2.87. Definitely a good idea to make the sketch. It doesn't have to be really pretty, as you can see, but it can be helpful, especially later when we make more complicated pictures. It's a good idea to just have the habit already made of drawing that picture. So we wanted the area to the left of 2.87. So 2.8 is here. And then the 7/100ths digit is right here. So we need 0.9979. The probability that z will be less than 2.87 is 0.9979. Okay. All right, so we have 3 more examples. For the next one, we want the probability that z will lie between -1 and 1. So as before, I'm going to start with a little sketch. of the region that we're interested in. This time it's not open-ended. Before it was just greater than or less than some amount. Now we want to go in between -1 and 1. Okay, so there's a couple of ways that we can do this. One way is as follows. This involves a z of 1. So let's see what our table tells us for a z value of 1. The area to the left of 1, 1.0, 1.00 in our table, is 0.8413. Okay. We want, though, not all of that area. We want just the area from -1 to 1. So we need to think about how to cut up this area and use it to help us get the area that we truly want. The area under the whole curve is 1. Right? The whole curve is 1. If the area under the whole curve is 1, then half of it has to be on either side of the mean, right? Using symmetry. So if I know that the area under the whole curve is 0.8413, then 0.8413 minus 0.5 is 0.3413. This will be the probability that z is in between 0 and 1. That is, it's this, in between 0 and 1. Because we've cut off the 0.5 that appeared to the left. So if the area between 0 and 1 is 0.3413, then this original question that we wanted, between -1 and 1, is 2 of those regions that are each 0.3413. So we need 2 times 0.3413, and that's 0.6826. So a little more involved, but with practice, it's easier. Fortunately, we will get more practice right now. So now we want to do materially the same question, only we want to know the probability that z will fall between -2 and 2. So as before, I'm going to start with a picture. So let's do that. So in between -2 and 2, that's what we really want. So, all right, so then as before, we'll see what we can get from our standard normal table. The area to the left of +2 in our table, that's 2.00 right here, 0.9772. But then we want really the area in between 0 and 2. That will be 0.5, which is the amount on the half, taken away from 0.9772. So the whole area from -infinity up to 2 is 0.9772. We're going to trim off the part that is to the left of 0. So the part from 0 to 2 is 0.4772. So the probability that z will be between 0 and 2 is 0.4772. Then, once again, we have 2 of those regions using symmetry that are each 0.4772. So 2 times 0.4772, 0.9544. All right. So by now you've probably figured out what's going on. In the first example on this page, we saw that about 0.6826 was the probability of getting a value within one standard deviation of the mean. Within two standard deviations of the mean, we're getting about 95.44% probability. And these two numbers should be really familiar. This should sound like the empirical rule right here. We'd had 68% of the data within one standard deviation of the mean, 95% within two, and then 99.7% of the data within three. So really this is the empirical rule. And what we're doing with this table is we're generalizing, or we're going to generalize, the kinds of problems that we had back in chapter 3, only then we're really able to just do 1, 2, or 3 standard deviations from the mean. With the table, we're able to do more different distances from the mean in terms of standard deviations. So, so that's exciting. So you can probably feel the hair coming up on your arm. So that's good. So the third one here, between -3 and 3, is probably going to end up being 99.7%. We should follow through with the details just for practice. So let's do that. So again, we want to know probability that z will be within 3 standard deviations of the mean. That's -3 to 3. So to help us get this done, we'll find the area up to +3 only. So taking a look in our z table, that's going to be right here, 0.9987. So 0.9987 will be the area from -infinity up to 3. So then the area from the center line to 3 well, if 0.5 of it is from -infinity to 0, then 0.4987 should be between 0 and 3. So the probability that z will be between 0 and 3 is 0.4987. So then, if we really want to know the probability that z will lie between -3 and 3, we found that there's 0.4987 on the interval from 0 to 3, and then using symmetry, it'll again be 0.4987. From -3 to 0, we'll need 0.4987 twice, and that's 99.74. Okay, all right. So take a look at that. Make sure that you can reconcile that for yourself with the empirical rule that we'd had before, and make sure you see how we're using the table, and then reasoning about how the table tells us values from -infinity to z, and how we're turning that into areas between negative one value and another. Okay, that will end this next part of 6.1. We have one more piece to do, which will show up in the next video.